In this art tutorial video, we'll learn how to use some new codes to help you with your Unit 10 R homework. And for this tutorial, we'll be using the Karloff dataset. So I'm going to import that. The Karloff dataset. I'm going to call it as Carl. Make sure that the heading is checked as yes, then import. You can also open up your Unit 10 pre-lab script to make it easier for you to use the new codes. In this unit, we're comparing the quantitative data in 3 different groups. These groups comes from our categorical variable, which is the moon phase, and our numerical variable will be our temperature. Question number 1 in our homework asks us to find the mean and the standard deviation of temperature for students in each moon phase group. This means that we're comparing more than one mean and standard deviation. And to do this, you don't need to run the mean function again and again, nor do you have to create separate new subsets. But instead, you can use a new code called the aggregate code. This function will help you look at the mean across all 3 different phases of moon, which are our group. Let's calculate the mean first. And we'll be using the aggregate code. In this function, you must have your variables first and then your data set, because this function is basically taking the numeric value as a function of a categorical variable. So our numeric value, which is our temperature, and then the tilde symbol, this means we're saying it is taken as a function of our moon phases, the categorical variable, moon.phase. Make sure you type the variables in the same manner as it is in the dataset, and if you're not sure how it is, you can go back to the dataset and find it. Next, you'll have to tell the function that which dataset you're using this and from where the variables come from, which is the Carl. And lastly, what is the actual function of variable that we're looking for, which is for now is mean. Then 1. Notice that we have 3 different means. These means are of temperature that are separated by the groups from the moon phases, which are the full, new, and partial. Next, we'll calculate the standard deviation. And to calculate this, we'll be using the same aggregate code that we used for the mean. You can copy this code from the pre-lab script as well, or type it manually. If you copy this code, make sure you have the correct variables and the correct data set. Now instead of mean, we have standard deviation. Then here we have all of our standard deviations. This will help you test this one of the assumption, which is the variability. To meet the assumptions, the standard deviations must be approximately the same. Next, we'll check the assumption of normality, and to do this, we'll need a visual representation, and for this unit, we'll be using the box plots. This will also help you answer question 2 and 3 in our homework. As we're comparing more than one group or more than one population, we'll have more than one box and whiskers. To make this comparison easier, we'll need all the box and whiskers in one single plot. And to do this, the code is similar to the aggregate code, but instead we'll be using the $sign. And then again the toad symbol. Note that you must have your quantitative variable first and then your categorical variable, the dot face. You can also have a title for this plot, which I'm going to say is temperature by moon phases. Your y-axis will be the quantitative variable, which is the temperature, and your x-axis will be your groups, which are the moon phases. Here we have all of our box and whiskers. Each one of them are labeled by their groups of the moon phases. This box and whisker plot will help you test the assumption of normality. To answer the rest of the questions, we'll have to run the Anova test. And to run this test, the function for this test is really simple, which is just AOV, and it is the same as the code we used for the box plot, which is call temp, and then the toad symbol, and call again the moon phases. To make it easier, you can also copy this code from the pre-lab script and then run. Notice that we just have the sum of squares and degrees of freedom, but in order to check the null hypothesis, we must have an F statistics and p-value to whether or not to reject the null hypothesis or fail to reject them. And to do so, we'll have to run a summary code. But before we do that, we'll create a vector, and let's call it as model temp. You can also copy the code from the pre-lab script. Do not run this code at the same time. Run each code one by one. Make sure you change the dataset and the variables. And if you change the name of the vector, make sure you change it every time you're going to use it. Next, we'll run the summary code. As I change the name, I'm going to change it again. And here we have the F value and the P value. We also have the mean of squares. This will help you reject or fail to reject the null hypothesis. In case if you reject the null hypothesis, you'll have to run post hoc test. This test runs multiple independent tests comparing the groups to each other. And for this test, the function we'll be using is the toKey. You can copy this code from the pre-lab script as well, which is right after the Anova test. If the F statistic is significant, and the code will be the Anova code as a vector, and then run. To check this test, you'll need a new alpha, a new adjusted alpha that comes from your initial alpha divided by the number of independent tests you run, which is 3. Our initial alpha was 0.05 divided by the number of t-tests that we run, which are the 3 tests, and this will be your new alpha.